Today's lecture is about cognition. Remember that from the ABCs of psychology, cognition refers to thinking. More specifically, you will learn what cognitive psychology is, get a broad introduction to the topic of judgment and decision making, and then learn about two ways that people can make decisions. Cognitive psychologists study processes related to thinking, including attention, memory, language processing, perception, and problem solving. Because cognitive psychology is a core part of psychology, you will notice that elements of cognitive psychology appear in other parts of the course. For example, you learned about attention and perception in the sensation and perception section, and will learn about cognitive development when you learn about developmental psychology. And you will learn about the role our typical patterns of thinking play in certain mental illnesses when you learn about psychopathology. Not surprisingly, thinking is an important part of our daily lives and of this class. Researchers in the field of judgment and decision making focus on what kind of decisions people tend to make, under what conditions, and why. The traditional view of human decision making, based in economics, was that humans will make rational decisions. This model assumes that our brains function as computers, taking in data, performing calculations, and acting based on the output of these calculations. This model assumes an objective process free from bias. As you will learn today, human decision making is often irrational. This, however, does not mean that it is totally erratic or unpredictable. Researchers who study judgment and decision making have identified many predictable biases that come into play when people make decisions. Today's lecture will introduce you to a few of them. One well-supported theory of decision making is that we make decisions in two major ways: a slow and careful way and a quick, low-effort way. The slow and careful way is called System 2 decision making, or more broadly, System 2 thinking. Thinking using System 2 takes effort and focus and involves a careful and rational analysis of information. We need time and energy to do it well. If you have a big decision to make and carefully create a list of pros and cons, you are engaging in a type of System 2 decision making. System 2 decision making often involves the type of computer-like, data and computation-driven approach that represents the most objective and rational way to make decisions. Consider, for example, 6 steps to making a rational decision. I will first present the steps and then show how they could be applied to making an actual decision. The first step involves defining the problem. The decision maker needs to be clear about the exact decision they're trying to make or problem they're trying to solve. The second step involves identifying the relevant criteria. These are all the factors that differentiate between good options and bad ones. The criteria then must be weighted or prioritized. Some criteria are more important for particular decisions and others are less so. Then you must list out the possible choices or options. Then each option must be rated as to how well it satisfies each criterion. Finally, the weighting can be taken into account and a score can be calculated for each option. The option with the highest score wins. If this sounds confusing, unwieldy, and like a lot of work, wait until you see me apply it to a simple example with limited options and criteria: how to spend spring break. Imagine that you have a week off of school for spring break and are trying to decide how to spend it. The problem is straightforward. What do you do for spring break? Next, you have to decide what the important factors in your decision are. For this example, I've decided that affordability, fun, relaxation, and time with friends matter. These are my criteria. Then, I decided that affordability is the most important criterion. I don't want to go broke just for a one-week trip, followed by time with friends, fun, and relaxing. These will all affect my decision, but they are not all equally important. After that, I consider my options. In this obviously completely fictional example, I have lots of friends who want to go on trips with me. My options are trips with friends to Italy, Miami, or San Diego, or staying home. The last two steps are the fun part because, at least in this example, they involve formulas in a spreadsheet. I assign different ratings to each option for each criterion. Higher numbers are better. For example, staying home is more affordable than going to San Diego, which is more affordable than going to Italy. And going to Italy is more fun than going to Miami or San Diego, which are both more fun than staying home. Then I applied my weighting by using a formula to multiply affordability by 4, friends by 3, fun by 2, and then add all the criteria, including relaxation, together. The weights are meant to represent the relative importance of each criterion. And voila! San Diego wins. Easy, right? Definitely not, but System 2 thinking is supposed to be a lot of work and also result in solid, objective decisions. At this point, I'd like you to pause and reflect for a moment. Does the 6-step decision-making process appeal to you? If so, what do you like about it? What kinds of decisions might you use it for? Have you ever done this or something similar? Although I consider myself to be a very rational person, I have never once spontaneously used a decision-making process that is this elaborate and methodical. Have you? Will you now that you have a specific system? If even thinking about going through the 6-step process makes you feel mentally exhausted, you may be relieved to know that a lot of our thinking and decision-making is relatively effortless. Perhaps because System 2 decision-making can be so much work, we also use System 1 decision-making. System 1 decision making is fast, automatic, emotional, requires little effort, and we are often not even aware that we are making a decision. Consider grocery shopping. Imagine that you want to buy ranch dressing. You could use System 2 and decide that you want to buy dressing that tastes good, is reasonably priced, and has a squeeze top. You would then have to decide how to weigh these criteria and compare your options. If you do it this way, it may take you the time another person would complete their entire shopping trip just to choose ranch dressing. Or you could just grab the first one that looks good. Maybe you chose it because of advertising, or because you ate it as a child, or because of a cute picture or cool font on the label. You probably don't even know why you chose it. This is System 1. Although in many ways System 2 is the gold standard of rational decision making, it is simply not practical to carefully consider every detail of each decision objectively. So sometimes we use our emotions, rely on shortcuts, ignore relevant information, and allow ourselves to be influenced by irrelevant information. The idea that we are not rational decision makers, when taken from cognitive psychology and applied to economics, radically changed the way economists viewed human nature and earned Dr. Daniel Kahneman a Nobel Prize. He worked extensively with Dr. Amos Tversky. However, Dr. Tversky died in 1986 and Kahneman received the prize in 2002. The Nobel Prize is not awarded posthumously. There are multiple ways in which people are not rational decision makers. Let's focus on 3 of them. We tend to be overconfident, we are affected by anchoring, and we are affected by framing. Overconfidence is pervasive in human thought, particularly in the US. In terms of decision making, what researchers mean by overconfidence is mainly people not being careful enough about decisions or questions about which they have insufficient information. In other words, at least under certain conditions, people seem overly willing to make wild guesses without realizing that they are wild guesses. The fact that we often aren't fully aware that we don't know something makes it difficult for us to notice our own shortcuts and biases, and if we don't notice them, there is little hope that we will correct them. Anchoring occurs when we have to determine a numerical value and we don't really know the answer. Because our answers are quick guesses, they are easily influenced by numbers that we hear or see prior to answering, even if they are not relevant or helpful. Even seemingly relevant information can introduce bias. For many things that we purchase, their value is not absolute, but determined, at least in part, by market forces. In other words, part of what determines something's cost is how much we are willing to pay for it. Sales take advantage of anchoring by including a price or suggested retail value, and then showing that it's being offered at a deep discount. The problem is that these original prices can be easily changed, so a high percent off doesn't necessarily make it a good deal. But if you're anything like me, a pair of jeans that are $60 marked down from $200 might seem intuitively a lot more appealing than jeans that are priced at $60. This happens for houses too. Home values are determined in large part by what people are willing to pay, which is why they can fluctuate so much over time. The amount for which homes end up selling is determined in large part by the listing price, which establishes an anchor in real estate agents' and buyers' minds. One of Kahneman and Tversky's most famous findings is that how a question is asked can dramatically affect the way people answer it, even if the factual information in the question remains the same. For example, we are more likely to choose options to maximize gain and to avoid loss. Consider the following example. Imagine that the United States is preparing for the outbreak of an unusual avian disease that is expected to kill 600 people. 2 alternative programs to combat the disease have been proposed. Assume that the exact scientific estimates of the consequences of the programs are as follows. Now imagine you can choose one of the 2 programs to respond to the outbreak, Program A or Program B. If Program A is adopted, 200 people will be saved. If Program B is adopted, there's a 1/3 probability that 600 people will be saved and a 2/3 probability that no one will be saved. Which would you choose? Most people, including me, choose Program A. The gain framing of saving lives sounds attractive, so we focus less on the fact that Program A also means that 600 people will die. Now imagine the same scenario, but you have to choose between Program C and Program D. If Program C is adopted, 400 people will die. If Program D is adopted, there is a 1/3 possibility that no one will die and 2/3 probability that 600 people will die. Which would you choose? Most people, including me, choose Program D. The loss frame of 400 people dying is so aversive that we want to avoid it. The risky option, in which it is possible that no one will die, seems more appealing. Notice, however, that Programs A and C are actually the same. 400 die, 200 live. And Programs B and D are also the same. 1/3 probability that 600 live and 0 die, and 2/3 probability that 0 live and 600 die. Our answers are far from rational. We give totally different responses depending on the way the information is presented. Let's review. At this point, I recommend pausing the video, putting away your notes, and seeing how much of the information from this lecture you can remember without looking anything up. I will read the review questions and then provide my own brief answer to each question. 1. What is cognitive psychology? 2. What are researchers who study judgment and decision-making interested in? 3. 5. What is System 1 decision making? More specifically, what is overconfidence, anchoring, framing? Cognitive psychology is the study of human thought, which also includes attention, memory, perception, language processing, and decision making. Researchers who study judgment and decision making are interested in how people solve problems, answer questions, and make decisions. They investigate the extent to which people are rational in our decision making, what kind of errors we make, why we make them, and when we tend to make them. System 2 decision making is slow, rational decision making. It requires effort and focus and involves carefully considering facts and data. 6 steps to a rational decision is an example of System 2 decision making. System 1 decision making is quick, can be based on emotion, and requires little effort or awareness. Overconfidence is an example of System 1 decision making that involves being more certain than we should be when we are guessing. Anchoring is an example of System 1 decision making in which our numerical estimates are influenced by numbers that we saw or heard earlier. Framing is an example of System 1 decision making in which we base our decisions on how the question is worded rather than carefully processing the information it contains. To be clear, although System 1 decision making can be biased and error prone, it is also probably necessary because we may not have the cognitive capacity to make careful decisions all the time.